Hey everyone, in today's tutorial, we're going to create a flammable actor. This will actually be part one of a three-part series. In this first video, we'll make the actor that can catch fire. In the second video, we'll learn how the fire spreads to nearby flammable actors. And in the final part, we'll see how the fire can be extinguished by another actor. Before we start, let's take a quick look at how fire behaves and make a plan. We'll build our actor in three stages. 1. Ignition stage, when the actor first catches fire. 2. Burning stage. When the fire grows stronger, the actor's color changes, and soot starts to appear. 3. Extinguishing stage, when the fire slowly dies out and the actor darkens or gets charred. For now, I've set each stage to last only 5 seconds. Of course, you can extend these durations in your own project if you like. First, we're going to create a new actor and give it a name. Let's call it cube_BP. Always name your actors. It really helps you avoid confusion later in the project. Let's double-click to open the actor. Now, we'll add a static mesh component, so we can actually see it in the world. For now, I'll just use a simple cube. Next, let's add a cascade particle system component. Don't forget to attach the particle system to the static mesh. That's important. Now, set the scale values of the particle system to 0, 0, 0. We'll change that later. All right, let's switch to the event graph and create a custom event. We'll name it Ignite. When this event starts, the fire will appear and gradually grow. Now, we'll make the fire grow slowly. Let's create a timeline. Double-click to open it and add a float track. This track will increase the fire's size from 0 to 4/5 seconds. Back to the event graph. We'll now change the world scale of the particle system. Let's place the actor into the world. Then, open up my character's blueprint. When I press the E key, the character will ignite this actor. The node getAllActors of class is a very powerful and useful one. It finds all actors of the same class in your game world and lets you make changes to a specific one in the list. Nice! It's burning now, but it's not moving yet. Let's enable physics on the actor, and there we go. Now we have a burning actor that can also move. With this setup, we can easily create a spreading fire in our game. Next, we'll move on to the stage where the fire reaches its peak, burning intensely and vividly. For this, let's create another custom event and name it Blazing. I want this stage to last about 5 seconds. During this time, we'll keep the fire at its maximum size, slightly redden the object's material to make it look like it's glowing hot, and make sure some soot or burn marks appear around the object's surface to give it a more realistic look. To make the object look more red and glowing, we'll need an overlay material. Create a new material and name it M_overlay_red. Then, assign this material as the overlay material for your actor. If you're having trouble finding it, just type overlay in the search bar. Now open the overlay material and change its material domain from opaque to translucent. Hold the 1 key and left-click to create a scalar parameter. Set its value to 0, and then connect it to the opacity input. Hold the 3 key and left-click to create a vector parameter. Pick a red color and connect it to the base color input. Once you save, you'll see that the object starts to shift toward red, depending on the opacity value. To control the opacity through code, we need to make it a parameter. Name this parameter opacity. Now go to the actor's construction script. This part runs before the game actually starts, so any code you place here will execute immediately. We'll convert the overlay material into a dynamic material instance, and then promote it to a variable. This will allow us to modify the material more easily later on. After promoting it, set this dynamic material on the static mesh. Then use the setScalarParameterValue node. Don't forget to type the parameter name exactly as opacity, or it won't work. Now, let's move to the event graph. Create a new custom event and name it burning. In this phase, we won't change the size of the fire. Instead, we'll make the object gradually turn red by increasing the overlay material's opacity from 0 to 1. Create a timeline and add a float track. Set it to go from 0 to 1 over 5 seconds. Connect your dynamic underscore overlay underscore ref to the set scalar parameter value node. And again, make sure the parameter name is opacity. Finally, if you want this to actually play in-game, call the burning event right after the ignite event finishes. All right, now it's time for the burned object to leave a scorch mark where it was. We'll do this using a decal. First, go to Google and search for burnt PNG. Look for a burn mark image. Make sure the image has a transparent background and is in PNG format. Download it and drag it into your content folder. Right-click on the image and create a material from it. Set the material domain to deferred decal and the blend mode to translucent. Connect the alpha channel of the texture to the opacity input, then save the material. Now go back to your actor's event graph and create a custom event called Create Decal. For now, connect it right after the Ignite event. Inside the event, call Spawn Decal at Location. Choose the decal you just made, adjust its size, and connect the static mesh's world location to the actor's location. Let's test it. Okay, now we have an object that instantly leaves a dark burn mark, but we actually want that mark to appear gradually during the burning process. So, we need a repeating event. Open the decal's material again and add a multiply node. Connect the alpha from the texture to it and set the multiplier to something like 0.2 so the mark appears softer. Then, at the end of the Create Decal event, add a delay node and set it to 0.5 seconds. Use a reroute node to loop it back. Nice. It's working now. But we'll still need a way to make it stop at some point. I want this burn mark process to start during the blazing phase. Now it's time for the object to extinguish. In this stage, the flames will gradually shrink, then turn into smoke. The smoke will also fade away after a while. And during this time, the object itself will darken. So, let's go to the event graph and create a new custom event called Extinguish. To be able to change the overlay material's color through Blueprint, we first need to make the color a parameter. Open the overlay material, turn the color input into a parameter, and name it color. Now, go to the construction script and add a setVectorParameter value node. In the parameter name, type color. Then, go back to the extinguish event and create a timeline. Inside the timeline, add a color track and set it to gradually transition into black. After that, get the dynamic underscore overlay underscore ref variable. Call setVectorParameterValue and type color in the parameter name. Finally, connect the timeline output to this node. And of course, don't forget to call the extinguish event at the end of your blazing event. Now let's shrink the fire and turn it into smoke. At the end of the extinguish event, add a timeline and create a float track inside it. Set the value to go from 4 at second 0 down to 0 at second 5. Then use Set World Scale 3D on the particle system. This will make the fire gradually get smaller until it disappears. Next, we'll add another particle system to the actor. This one will represent smoke or steam after the fire goes out. Place it just before the first timeline inside the extinguish event. Use Set Template to assign a smoke or steam effect. Finally, at the end of the fire's timeline, create a new timeline for the smoke, so the smoke will also fade out, its scale going from 1 down to 0 over 5 seconds. Also, I don't want the object to keep leaving burn marks after it's extinguished. To handle this, we need to create a control point. Otherwise, the event would run forever. I'm creating a Boolean variable called IceExtinguished, and at the end of the extinguish event, I'm setting it to true. Now, let's go back to the createDecal event. Here, I'm adding a branch node and connecting our Boolean variable to it. This way, each time the event loops, it will first check whether the actor has been extinguished. If not, it continues. If yes, it stops leaving new decals. This way, the fire smoothly transitions into smoke, and both effects end naturally, just like in real life. As you can see now, the object slowly darkens. Our burning sequence has a proper ending. All right, that's all for this part. We've created a fully functional burning actor, one that ignites, blazes, and extinguishes realistically. In the next video, we'll take it one step further and make the fire spread from one actor to another. Thanks for watching, and don't forget to save your project before you continue. See you in the next one.